Ferrari's 2026 weight reduction program draws directly from its hypercar operations. The transfer of knowledge from the 499P Le Mans winning project to the 678 Formula One car represents one of the most significant technical advantages Ferrari holds over customer teams. The weight distribution strategy centers on three core areas: transmission packaging, battery architecture, and powertrain integration. Unlike competitors who must coordinate with external suppliers, Ferrari's vertically integrated structure allows simultaneous development of all major components under one roof at Maranello. The transmission represents the second heaviest component after the power unit and batteries. Engineering sources indicate Ferrari is pursuing a more compact gearbox casing, not simply to save mass, but to enable a narrower rear bodywork profile. This creates a cascading aerodynamic benefit: less drag, improved diffuser efficiency, and cleaner airflow through the critical underbody section. What this really meant was that Ferrari could optimize the rear-end architecture in ways customer teams cannot. When you control both the gearbox design and the chassis integration, you can make packaging decisions that would be impossible if those components came from different suppliers. The gearbox compacting isn't just about weight. A narrower transmission allows the diffuser to work with fewer obstructions ahead of it. Air can flow more freely under the car, generating increased downforce and efficiency. Engineers can also position masses more strategically, optimizing the center of gravity and improving load transfer characteristics during cornering. The battery pack presents a more complex challenge. The 2026 regulations increase electric power output from 120 kilowatts to 350 kilowatts, nearly tripling the electrical component of the hybrid system. This requires significantly larger battery capacity, which typically means additional weight. Very few people noticed that Ferrari's WEC program had been working on precisely this problem for 3 years. The 499P Hypercar operates with a sophisticated hybrid system, and the engineers managing that program accumulated substantial experience in high-performance battery optimization, thermal management, and power electronics integration. This knowledge transfer isn't a direct technology migration, as the regulations differ considerably between WEC and Formula One. Rather, it's a transfer of methodology, problem-solving approaches, and engineering philosophy. The personnel who developed solutions for the 499P understand which approaches succeed under competitive pressure and which fail. They know how to balance weight against performance and reliability. They understand battery packaging optimization, cooling system integration, and power electronics management. This institutional knowledge is now being applied to the 678 development program. The decision to use a steel alloy cylinder head initially raised questions about weight penalty. However, as we've previously documented, the additive manufacturing process used to produce these components allows for wall thickness optimization and complex internal geometries impossible with traditional casting or machining methods. When combined with the compact transmission and lightened battery pack, Ferrari's engineers believe they can achieve a total weight figure competitive with, and potentially superior to, teams using more conventional material choices. The steel head's thermal advantages also permit smaller cooling radiators, creating further mass savings and aerodynamic benefits. Ferrari's ability to develop the entire car within a single facility represents a structural advantage that shouldn't be underestimated. Customer teams like McLaren, Aston Martin, and Williams must coordinate engine integration with external suppliers. Ferrari develops engine, chassis, suspension, and electronics, all at Maranello. This enables tighter integration, faster communication between departments, and an iterative optimization capability that customer teams fundamentally cannot match. When powertrain engineers can walk down the corridor to discuss packaging constraints with chassis designers, solutions emerge more rapidly than when those conversations require formal supplier meetings and data exchanges. The 678 adopts pushrod suspension front and rear, replacing the double pull rod configuration used on the SF25. Technical Director Loic, a vehicle dynamics specialist, used data from the updated rear suspension package that debuted at Spa to understand which approaches to avoid for 2026. development focus has centered heavily on chassis work, with tire utilization as the primary concern. The engineering team wants to understand precisely which conditions allow the Pirelli compounds to generate maximum grip. Sarah's background in vehicle dynamics means tire comprehension takes priority over pure aerodynamic development. Reports suggest Ferrari is pushing hard on outwash efficiency through side pod design. The undercut section housing radiator inlets is expected to be particularly pronounced. Work on engine cooling masses should enable a narrower rear end profile, critical for diffuser performance. A tighter rear section reduces aerodynamic drag, increases straight line speed, and importantly allows more downforce generation from the diffuser. The area the diffuser must work with needs to be as clean as possible, free from obstructions that disturb airflow. Ferrari has finalized the launch specification that will complete the 678's first running at Barcelona from January 26th to 30th. This test will validate power unit choices, bodywork decisions, and confirm that all data aligns with simulation predictions. Subsequently, at Bahrain on February 11th to 13th and 18th to 20th, the car will see its first development updates, following the same pattern as other teams. On either the penultimate or final day at Sakhir, Ferrari will introduce the aerodynamic package that will then appear at the Melbourne season opener. The collaboration between Formula One and Hypercar programs appears to have delivered tangible benefits. The 499P's Le Mans victory and WEC championship success came partly through intelligent weight management and energy deployment. Engineers working on that program developed valuable expertise in optimizing high-performance batteries, managing mass, and integrating hybrid systems. This experience is now flowing from Hypercar to Formula One, not as direct technology transfer, but as methodological transfer. The engineers understand which solutions function under competition conditions. They can balance weight, performance, and reliability effectively. They know battery packaging optimization and cooling system integration. This institutional knowledge is assisting Ferrari in developing a lighter, more efficient 678. Combined with the steel cylinder head, optimized through metal additive manufacturing, a more compact transmission, and a lightened battery pack, Ferrari may achieve a highly competitive total weight figure. The single facility construction capability represents an advantage Ferrari intends to exploit fully. While customer teams must coordinate with external engine suppliers, Ferrari controls everything internally. Engine, chassis, suspension, electronics, all developed at Maranello. This permits exceptionally tight integration, rapid interdepartmental communication, and iterative optimization that customer teams simply cannot replicate. It's a fundamental structural advantage that compounds across the development cycle. Ferrari's approach to the 2026 regulations demonstrates a coherent technical philosophy. Leverage vertical integration, apply WEC-derived knowledge, optimize weight distribution strategically rather than uniformly, and prioritize aerodynamic efficiency through packaging discipline. The steel cylinder head choice, initially controversial, now appears part of a broader weight management strategy where mass saved in transmission and batteries offsets any penalty from the head material. The thermal advantages of steel then enable smaller radiators, creating further savings. What remains to be validated is whether this integrated approach delivers on-track performance. The Barcelona test will provide initial data. Bahrain will show whether development direction is sound. Melbourne will reveal whether Ferrari's strategic choices translate into competitive advantage. The organization has worked with operational discipline and technical maturity. Once on track, performance will provide the definitive verdict on whether knowledge transfer from Le Mans to Formula One has delivered the anticipated benefits.